Refraction through a rectangular glass slab. Let us now perform an experiment and find out how light gets refracted when it is incident on a rectangular glass slab. Apparatus: a drawing board, rectangular glass slab, drawing pins, sheet of white paper, a protractor and sharply pointed pencil. Procedure: let us consider a drawing board with a sheet of white paper fixed with drawing pins. Keep the rectangular glass slab in the middle of the drawing sheet. Mark its boundary ABCD with a pencil. Remove the glass slab. Draw an incident ray IO on AB. Draw the normal at point of incidence NON dash. Fix two pins P and Q on the incident ray IO. Place the glass slab within its boundary ABCD. Looking from the other side of the glass slab, fix two pins R and S such that your eye and the feet of all the pins are in one straight line. Look through the glass slab along the plane of the paper from the side CD and move your head until the images of the two pins P and Q are seen clearly. Closing your one eye, adjust the position of your head in such a way that the images of the pins P and Q lie in the same straight line. Fix two pins R and S such a way that your eye and the feet of all the pins are in one straight line. Remove the slab and also the pins from the board and encircle the pinpricks on the paper with a sharp pencil. Join the position of tip of the pins P and Q and produce the line up to AB. Let PQ meet AB at O. Similarly, join the positions of tip of the pins R and S and produce it up to the edge CD. Let RS meet CD at O dash. Join OO dash. It is a refracted ray. Measure the angle of incidence, angle I, angle of refraction, angle R, and angle of emergence, angle E, respectively. Angle I greater than angle R, and angle I equals to angle E. Also produce PQ up to P, as shown by a dotted line. The emergent ray is parallel to the incident ray. The above experiment shows that when a ray light is passing from air to glass, from a rarer medium to a denser medium, the refracted ray bends towards the normal drawn at the point of incidence. In this case, angle I greater than angle R. When the ray of light is passing from glass to air, that is, from a denser medium to a rarer medium, the refracted ray bends away from the normal. In this case, angle R greater than angle I. The emergent ray, O-E, which is nothing but the refracted ray emerging out of the glass slab, is parallel to the incident ray. This means that the refracted ray, emergent ray, has been displaced from its original path by distance xy. This displacement is referred to as a lateral displacement. Now, you're familiar with the refraction of light. Refraction is due to change in the speed of light as it enters from one transparent medium to another. Experiments show that refraction of light occurs according to certain laws. The following are the laws of refraction of light. 1. The incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. 2. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. This law is also known as Snell's law of refraction. If I is the angle of incidence, and r is the angle of refraction, then sine I by sine r equals to constant. Equation 4. This constant value is called the refractive index of the second medium with respect to the first.